Hi, everyone. My name's Matt, and I've been in an on-again, off-again relationship for the last several years. It's been a harmful relationship. It's not been good for my health. And of course, that relationship has been with core data. It started out as mostly a hate relationship, and I would say now it's kind of a mixed 50-50, some love, some hate. But I've learned to be able to live with it, and when I look back at the last couple of years of why I've hated core data, it's usually been because of performance reasons. And so once I figured out some of the tricks or some of the techniques you can use to get around those performance bottlenecks, I started to really like core data. And so I'd like to share with you guys some of those things, and hopefully it'll improve your relationship with core data. And so today we're going to talk about tools, we're going to talk about fetching, predicates, searching, importing data, concurrency models. We're going to try and cover a large group of things, and it's going to kind of be like a tapas type of talk. And hopefully there's at least one or two new things in here you haven't seen before, and it'll help you with your core data apps. And so core data is an object graph. Some people like to refer to it as a complicated database or just a way to persist data. Persisting data is just one of its features. And so if you check the tick box when you're doing a new Xcode project and you select the template and you get the core data option, you're going to get this stack. And it's going to have a main queue, a main manage object context. It's going to have one persistent store coordinator, a persistent store, and it's going to use the SQLite to actually persist your data. And so core data it's really good at managing 10,000 objects, maybe even more. You can do easily terabytes of data with SQLite, so there's no reason why it has to be unperformant. And so really the reason that we run into these performance issues is I think because the framework is so flexible that we we pigeonhole ourselves into spots where we're not supposed to be using core data, or in techniques or ways we're not supposed to be using core data. And over the last couple of days, several of you come up to me and quite aggressively said that you don't use core data. For reasons of it's too much code, it's too complex. And just a quick tangent is that you can actually set up this stack with like 6 lines of code. It doesn't have to be complicated at all. So when we talk about optimizing core data, it's really a balance. You've got memory and speed are the things that you're trying to optimize. And so on one hand, you want to have as less memory as possible, but you want it to be as fast as possible. And so the way you do that is by having more objects in memory. And so objects can live in 2 places. They can live on disk or in memory. Objects in memory are fast, but of course they take up more space. Objects or the representation of those objects on disk are slow, but they don't use as much memory. And so on Mavericks, we can utilize much more memory. Most of the Retina MacBook Pros now are shipping standard with 8 gigs. Most of us in this room probably have the 16 gig version. And so we can afford to put most of our object graph in memory. And therefore, it puts us more on the fast side of the speed continuum. But on mobile, with iOS 7, we don't have as much memory. I think the iPhone 4, which has iOS 7, or supports iOS 7, only has 512 megabytes of RAM available. And so you have to change your position on this continuum, and therefore, less of your objects can live in memory, and therefore you're slower. And so I built this app. It's a Ufo Sightings App. And the reason I picked this app is because there's a lot of UFO sightings in the world. People seem to think UFOs exist, so there's whole databases out there of UFOs. And these are the type of people that tend to write very verbose reports about UFO sightings. So there's a ton of text data in this app, and it's got 60,000 UFO sightings. It has a picture, unique shapes, the dates that they were seen, all kinds of metadata in it. And it's a good example to illustrate some of the performance issues. What I'm showing here is the actual performant version of it. And so throughout the course of this talk, we're going to build this app and make it performant. And so whenever I'm doing core data performance stuff, I like to follow this method of measure, make your change, then verify it. And so you want to do this objective measuring, because if you're just randomly changing stuff, you're going to find core data's rough edges. And so how do you actually measure stuff with core data? Well, you use tools. And so from app to app, the data models are going to change, the amount of data you're using is going to change, and so I can't stand up here and give you one right answer on how to optimize core data. There's not one right solution. You have to make measurements, and it depends on your app. And so luckily, we have plenty of tools to do this, but your tools don't have to be complicated. It can be a simple macro. So this is a TikTok macro that I like to use, and it's just a quick way to measure the performance of a single method. It's just using the time interval since now on NSDate. And if you were to measure a method, you just use it like this. You can also use launch arguments to kind of look and see what core data is doing behind the scenes. I use this one a lot, coredata.sql debug, and you just edit your scheme and pass this in as a launch argument, and you can change the verbosity of it by the suffix with the 1, 2, or 3 with increasing verbosity. And if you enable this, you're going to get a lot of output here at the bottom, and you're going to see actual SQL statements. So if you come from a SQL background, this stuff will make sense to you. You'll also get times that it takes to execute those SQL queries. But that's not the only launch argument. There's a bunch of other ones that Apple publicly documents. But unfortunately, it depends on which version of Xcode you're using. It seems that these are increasingly not being enabled. And so with the latest Xcode, these two don't work. And these are probably the threading debugging one is probably the most unfortunate one, because that one's actually pretty useful. So I'm hopeful. I leave it here because I'm hopeful that the next version of Xcode will have it. But your Macs also come with a SQLite tool. It's on all Macs. And it's a command line tool that allows you to dive into your actual core data-backed SQLite database and kind of look at the schema. And so if you wanted to see how core data is organizing itself, you could just run a select all from SQLite master, and that'll give you the schema. And so this allows you to investigate your data and kind of do performance metrics on it on the SQLite side instead of in Xcode or instruments. And so if you wanted to see how many unique UFO shapes you had, you could do the count function and group by shape. Those Z prefixes are what Apple uses in their core data implementation, but it's still easy to understand. Of course, there's a bunch of other SQL type of tools. SQLite Professional is a good one, but then there's also core data aware type of tools that are free. Pony Debugger is a free tool that allows you to see into your model. You can't really change stuff, but you can actually see what your model's doing. Core Data Editor by Thermalcore is also a core data aware editor that allows you to actually edit data. I don't really recommend modifying the SQL file that core data uses. Apple's freely available to change that whenever they want, but it is a good idea to read and analyze that data. Of course, the best option is to use instruments that comes with Xcode, and you probably want to use the core data template to start out with, but the time profiler and the file activity tool are also very useful. So for the tools, they don't have to be complicated. You can just use macros. Launch arguments, of course, depending on if they work. It's just SQL under the hood, and instruments is obviously the best tool to use, and always measure, measure, measure before you make changes. So let's talk about fetching. In general, don't fetch more than you need, but fetch just enough so you don't have to keep going back to disk. And so here's the app running in Xcode, and I'm going to launch it here. This is before I've done any optimizations, and I'm scrolling. It's scrolling fine. Everything looks good. Again, this is in the simulator, so I have a high-performance Mac running it. But if I look at the gauge, it says I'm using 125 megabytes of RAM. And so on a Mac, that's not an issue. But on an iPhone 4, that possibly could be an issue, depending on what else the user is running. But let's get a more objective measurement and actually profile this in instruments. So if I launch this in instruments, and I'm going to select the core data template, and we'll give it a second here to launch. And so it's launched, and I'm scrolling around just so we can get some good measurements. Everything's still smooth, but if we look at instruments here in the top, you'll see these thick bars. And so these are the core data fetches. And a thick bar like this is not what you want to see. You'd rather have this nice and thin, maybe only a pixel wide. These large bars mean that something's blocking. And so when we launched the app in instruments, there was a long time before it started up. And that was because of this massive fetch it was doing at the beginning. And it took 1.2 seconds, according to this. So again, this is a 60,000 UFO sightings. So we can expect large times. And I picked the large data set like this just so it's explicit on what is happening. And so we can fix this just by creating a batch size. This single line of code is often missing in a lot of projects that I come across. And this is one of the first things you can do to reduce your memory usage is actually set a fetch batch size. And the way I set this is by seeing how many visual items I'll have on screen at one time. So if I have 10 rows in a table view that's backed by core data, I'll just double that number and make my batch size 20. Usually that's good enough for table views because the user can't scroll faster than that. So once I set the batch size, let's see how that impacts the memory. Again, I'm going to launch Xcode, run the app. I'm scrolling, everything's performant. I look at the memory gauge. This time it went down from 120 megabytes to 20 megabytes, so we saw a 100 megabyte reduction there. But again, let's get an objective measurement. And so I'll hit record on instruments. It'll relaunch the app. I'll scroll a little bit. It's still smooth. And in the background, you can start to see more measurements happening in instruments. And also now, if we look at those lines where we looked last time, before they were really thick, now they're super thin. They still could be much thinner. They're still several pixels wide. Ideally, we'd get that even thinner. But again, we're using a database of 60,000 objects. So there are limitations. Now, if we zoom in and look at these fetches, it went down from 1.2 seconds to a half a second. And that's just the count. And then we'll see these batches coming in. It's 20 at a time. And so our memory usage is much lower, and it's because we're batching now. So let's say you had a view where you wanted to have some kind of summation of data. And so for my UFO Sightings app, I want to count how many times each unique shape occurred. And so how could I do that in core data and still be performant? Again, 60,000 objects, so I have to go through all that and count all those objects. There's several ways you could populate a view like this. Probably the worst way is to just do a massive fetch and fetch all of these objects into memory and iterate over every single object and count the unique shapes manually. It's going to be the slowest approach, and that's because you're fetching everything into memory, and then you have to manually iterate. A slightly better approach would be to set your result type to NS Dictionary and then specify which property you want to fetch on that object. And you could say, I just want to fetch the shape. But again, you're still going to have to iterate over everything and count these unique shape items manually. Another option, a better option, would be to use the count for fetch request method on manage object context. The problem here is that you have many unique shapes, so you're still going to have to do 20 different of these executions, and so it's still going to be not the best option. Really what you should do in a situation like this is let SQLite do the calculation, and so you can use NS expression to do that calculation. So NS expression is kind of what your predicates are built off of. You have a left-hand and a right-hand side of your predicate, and those are just NS expressions. And so here I'm going to use the count function, and I'm going to count shapes, and then I'm going to group by shapes. NS expression does a lot more than just counting. You can do average, sums, min, max, all the common math functions. But it also does a little bit more complex stuff like ceiling and standard deviation. So definitely check out NS expression. Another thing you can do to improve your fetch times is to prefetch your required relationships. So if it makes sense in your user workflow that one object is going to be viewed, and then immediately they're going to go to the next object that is tied by a relationship, it might make sense to prefetch that relationship. And so for my UFO Sightings app, if I have the photo stored off in a separate entity, but every time the user goes to that UFO sighting entity, it might make sense to prefetch that photo. And you can easily set prefetch parameters with the set relationships key paths for prefetching. Another option to improve fetching is to fetch in the background. So for long fetches, you should probably do them on a private background queue. And the way you would do that is to create a background context using the private concurrency type, and then you would call perform block, but you would set the result type to only return the object IDs on that private context. Once you had those object IDs, you could go back to the main queue, your manage object context that's specified with main concurrency type, and then you could grab those objects with that ID using the object with ID method, and then you could do whatever you wanted with the UI. So when fetching, just don't fetch more than you need, but make sure you fetch enough so that you're not constantly going back to disk. Don't forget to set that batch size. Use SQLite if you have complex calculations. NS expression is extremely powerful. And then fetch in the background when it makes sense. Let's talk about predicates. I mentioned earlier that you should only fetch what you need, so how do you do that? Well, you do that with predicates. And when you're working with predicates, you should really do light comparisons first. So when I say light comparisons first, obvious answer there is numerical comparisons. So computers are good with math. And in this example here, I wanted to get all shapes that are of the sphere style, but with a duration of 30 seconds. So they were seen in the sky for 30 seconds or more. And I did shape equals sphere. But a better approach would be to switch those and do duration first. And so the numerical comparison will limit the amount of string comparisons that have to happen after the numerical comparison matches. String comparisons are expensive, so when possible, don't use them. But be cautious when you do. And if you do use them, this is kind of the continuum of cost when doing string comparisons. Begins with and ends with are going to be much quicker. Equality is going to be a little bit slower. Contains and matches are going to be the slowest. Matches in particular is going to have to fire up a regular expression engine. And of course, case and diacritic insensitivity is going to cost you even more. So if possible, avoid that. So with predicates, do your numerical comparisons first. Begins with and ends with is a better way to build your predicates, and don't use case and diacritic insensitivity. So let's talk about searching. When someone's searching for data in your app, it's because they want to actively try to do something, and they want to make that action happen immediately. And so if searching is taking a long time, it's going to be a frustrating experience. One way you can improve searching is by canonicalizing your string properties or normalizing them. And so what that means is you can turn your crazy entries that these people have reported into something that's more friendly for searching. So for example, green men, you would remove the diacritic, you would make it lowercase, beam, you'd make all lowercase, same thing with probe and abduction. And so if you want to do this normalization, it's quite easy. These are the two functions you should look at. See if string normalize and see if string fold are extremely powerful and performant. If that's not fast enough, you could go another step further and canonicalize your tokens. And when I say tokens, I mean the words in these sentences you could separate out into individual words and then search across each word from those sentences. And so in a model form, this is what it would look like. You could take out those tokens and put them in a separate entity. And now you can use begins with on that tokens entity. And once you find a match, you could follow the relationship back to the original UFO sighting entity. And again, begins with is going to be much faster than using a contains or matches. And so you can easily create these tokens just by using components separated by characters and set on NS string. If that's still not fast enough, another option is to use a separate stack. So you could have two core data stacks that have, one is on background queue, and that's for your searching, and another one could be your primary queue for your UI work. The thing is, if you do this, you can't share objects between the two stacks. You can't use object IDs. The object IDs are from the persistent store corner. You can't use that. The only thing you could do is maintain URI representations between the two. If that's still not fast enough and you still need better searching, probably your last option is a hash of tokens. You could take each word or token and take the first 3 letters of every single one of those tokens and just store that in a hash in memory. Even with 60,000 UFO sightings, it's still not that big of a memory issue. So for searching, normalize your text properties, use tokens, separate persistent stack if you have to, and if you really, really have to, you could use a hash of tokens. Of course, this is increasing complexity, so you shouldn't go straight to hash of tokens. You should use the easiest method possible. Let's talk about data model. So data models vary from app to app, but there are some common things you can do. One is to not over-normalize. You should let your view dictate what your model looks like. Duplication of data in a core data model is completely fine and maybe even encouraged. And so you should ask yourself questions like, what lists are needed, and how many items on that list will there be? After I have this list, when I tap on an item, where does it take me? Those are the type of questions you should ask yourself when you're designing your model. If you have large binary blobs, like I do in this UFO sighting app where I have photos, you should consider using checking the allows external storage option. And then core data is going to decide if it should persist that data on disk or in the SQLite database. So for my app, I have the photo entity on the UFO sightings. But if I don't need the photo every time I access a UFO sighting entity, it might make sense to move that off to a separate entity. And so I could put the large photo blob off in a separate entity, and then that way when I grab my UFO sighting entity, I don't have as much data. This all goes back to just fetch as little data as possible. But in my case, for the UFO sighting app, I do have a picture on each row. It's a thumbnail. And so for me, an even better option would be to store a thumbnail on my main UFO sighting entity, and then off in the photo entity, store the large photo, the full resolution photo. Again, less data takes less time to fetch. So when you're talking about your data model, don't over-normalize. Use external storage for the large attributes. Large blobs, put them in a separate entity. If it's a photo, just maintain that separate thumbnail in your primary entity. And again, less data takes less time to fetch. A quick note about app launch times. If you need to do a database migration, that can take an indeterminate amount of time. And so you really should set up your core data stack asynchronously, and then on the main queue, post the notification that, hey, my core data stack is set up. And then you can notify your view controllers that, hey, now you can actually hit the database. There's this another issue I'd like to mention, and I call it the lots of things problem. So say you're an RSS reader and you want to mark all feeds as read. How do you do that? To be honest with you, there's not a good solution. You have some options, though. You could maintain a is-deleted flag on all your entities and all your predicates filter by that, and then at some other time when it makes sense, you could remove those is-deleted items. When the app goes in the background, you could do a background task, and you get about 5 minutes there. You could iterate over all your objects and delete them. You could do it when the user's in the settings part of your app, or when they're in transitions, or where the app isn't actually hitting core data. Those are good times in the background to actually delete all those entities. But really, those aren't really great solutions. The real solutions would be something like this. These are the APIs that we actually need. We need a delete objects matching predicate, and we need a update properties for object matching predicate. And so I encourage you, if you agree with me, to dupe these radars. So let's talk about importing data. So a lot of apps need data to be useful, and if that data is static or never changes, you could probably just ship it with the app, and you probably should. But if it's dynamic or user-generated, it probably needs to be imported with some kind of network request of some kind. And so for my UFO sighting app, let's see what importing looks like. And so I'm going to launch instruments, launch the app. And so I'm scrolling around, everything looks fine, and then I'm going to go ahead and tap the import button. And now I'm going to do a large import. And right now I'm trying to scroll it. It's hard to see because I'm using the mouse pointer, but it was blocking the UI. I couldn't scroll at all. And if we go back to the instruments window, we can kind of see what's happening. And I'll fast forward this. So again, 60,000 UFO sighting objects. Took about 5 minutes to import them all in. And it's solid blue and purple there. And so it was blocking the UI the whole time. So let's see if we can fix that. The quickest way to fix that would be to move off that import from the main queue and put it on a private queue. And so it was blocking the UI because we were on the main queue. And so it's pretty easy to do that. We can just create a new manage object context with the NS private queue concurrency type, and then we can perform that import on that private queue. And so if we make this change, let's see what happens. Again, I'm going to launch the app in instruments. And I'll scroll around a little bit. It's performant. I'll hit import. And now this time, I can still scroll the UI. Before, this would have blocked, and it wasn't scrolling at all. And so now that it's scrolling, we know we're not blocking the UI anymore. But it's still going forever in the background. Let's see how long it takes. Again, I fast-forwarded it. So 4 minutes, we shaved off a minute just by putting it on a private queue, but still, it's unacceptable. And so why was it unacceptable? It's because I used a immature import algorithm, I would say, and it's one I see examples of in the Apple docs, too. And so what does that algorithm look like usually? It's a JSON to NS dictionary. You find your existing object. If it doesn't exist, then you create it, or you do an update, and then you repeat for every single JSON item. And the issue here is that you're fetching one object at a time, so you're going to core data manually every single time. A better approach, a more efficient approach, would be to sort your import objects by ID first, then execute a single fetch, bringing all those objects that match those IDs in, and then iterate through both the import objects and the existing objects, and then update or create as necessary. So what did that algorithm look like? So if we have our new data on the left here, and those are their IDs, it's unsorted, and then we have our existing data on the right, also unsorted. First step would be to sort them. Once they're sorted, we could iterate over each of these arrays. So first we'd look at ID 1. It's an update on both sides, so we would just do an update. We'd increment the counter. We'd look at the other 2 and 4, and that's an insert, so we would do an insert. This time, we would only increment the counter on the new data side. Existing data pointer would stay the same. And then we would do a comparison again, and we would see that it's an insert. Again, you just keep going through this process of iterating through each of these objects and seeing if it's an insert or an update. So if we change this more efficient algorithm, let's see how that impacts our app. Again, I'm going to launch instruments. I can scroll the app. It's fluid still. I'll hit the import button. I can still scroll the app. It's not blocking the UI. And in the background, we can see it going. It went down from 4 minutes and 20 seconds down to a minute 20. So by improving our algorithm, we shaved off another 4 minutes. You can look at the allocations there, and that looks scary. That's over hundreds of megabytes of JSON data. And so really, we probably should be streaming that JSON file. That JSON file is living in my app bundle, so that's a separate issue. But the time profiling, we've shaved off 4 minutes. So we're making good strides. So how can we fix that memory issue? We can improve that import algorithm with batching. And so we would still sort the import objects by ID, and then we would execute multiple fetch requests based on a batch size. And so how do you determine that batch size? It's kind of an experiment you have to run on all the devices you support, and it depends on your data model. So you have to run it on the least supported device and figure it out until you can come up with a good batch size. And so if you were going to do this batching, this is how you do it. You use the in function on your predicate. And so this is very common in the SQL world, but a lot of people that are new to core data don't know about using in. And so you would group it by your JSON batch GUIDs. Another option would be to use pre-populated SQLite files in your app bundle. So you could ship SQLite in your app bundle, and then at app launch, you could copy that SQLite file over to the user's documents directory, and then add that to your persistent store. And sometimes this is possible, but if you have data that changes or is dynamic or unique to that user, obviously that's not an option. What you could do is use a Mac server and download pre-populated SQLite files from that server. You could do this dynamically. Core data does not have a UI kit requirement. You could build a command line tool that just generates these core data files on the fly. But that's probably not recommended. You probably want to generate these files every so often and serve them up statically. So for importing data, you should do import work on private queues. Use a better, efficient find-or-create algorithm, and work in batches to keep your memory low. And if you have to, you can use a pre-populated SQLite file. So a quick note about memory. If you're done with an object, you can get rid of it by calling refresh object merge changes. That API doesn't really make a whole lot of sense in that regard, but that's how you would do it. But if you want to throw away a whole context, you could just call reset, and that'll turn everything back into false. Let's talk about concurrency models. A time's going to come when you're going to need a background task. Maybe it's a long fetch. Maybe you need to update a lot of data. Fortunately or unfortunately, we have many concurrency models we can use. So this is the basic one that Xcode will give you if you check the template. This is probably what you should use. You shouldn't deviate from this unless you need to and you have a performance reason to do that. The main problem with this is that when you are reading, you can't write, or when you're writing, you can't read. You can't do those things at the same time. It's one queue. So you could go to a stack that looks like this, where you have a private queue and a main queue, and they share a persistent store coordinator. And with iOS 5 and 10.7, we got confinement types. And so the main queue confinement type is what you'd want to do for your UI work, and then you could do a private queue for your background work. When using this approach, you should use the perform block API, though. There's still a problem here, is that when you're importing on the private queue, the persistent store coordinator is still going to lock. And so the main queue is not going to be able to do reads from here. And that's because the persistent store coordinator is a serial queue. It'll only do one thing at a time. And so if you're trying to persist things to disk via an import algorithm, you're not going to be able to retrieve things from disk at the same time. So one way around that would be to take advantage of the merge changes from notification. But there's probably a better approach. If you're doing a large import, you might want to just wait until that whole import operation is complete and then refresh the whole table. There's no sense in merging a bunch of changes that the user can't see. There's another stack that's gaining popularity, and that's using parent context. And so with iOS 5 and 10.7, we got the ability to set a parent store to another managed context instead of a persistent store coordinator. And so the main queue could talk to the private queue, and the private queue could talk to the persistent store coordinator. And so you do your UI work on the main queue, and then you would do your persisting to disk on this private queue. But really, when importing data, you're still going to block the UI. You still only have one main queue. And still, your persistent store coordinator is still a serial queue, so it's going to block whenever you try to write or read at the same time. So I've even seen this stack out there. And so in this approach, you could do your background updates or your imports on a private queue. It could save to the main queue where your UI work is done. And then you could go finally persist to disk on that private queue. But we still have the same problem where the persistent store coordinator is still a serial queue. It's still going to block. Another problem I don't like about this approach is that you got to do crazy nested blocks to save these contexts. And so I've removed the error handling just so it would fit on the same slide here. But that's 3 blocks, 3 levels deep. So these are kind of the 2 approaches that are becoming the most popular approaches in our community. And the nested manage object context, where you have a parent context, I think is kind of a niche case. Maybe it's the use case is a scratchpad where the user kind of can create a new document and it's a draft and they can just throw it all away or save it, and the parent needs to know all about those changes. But if you're importing data, then I think this Y structure on the right is probably the best bet. But there's a third approach you could take, and that's this. You could use 2 persistent store coordinators, but talk to the same store file. And so when you're doing that large import on the private queue, yeah, it's going to block that persistent store coordinator on the private queue and block the persistent store, but that main queue is not going to be blocked at all. A file lock is much faster than a persistent store coordinator lock. And then with iOS 7, that file lock doesn't even exist anymore. They enabled write-ahead logging mode, wall mode, instead of journaling mode. And so now you can support multiple concurrent reads and one concurrent write at the same time. Again, the same context did save notifications happen. You can still merge those changes. But again, you probably don't want to do that if the user can't see those changes. The better approach would be to refetch and reload your table after the import completes. So let's make this final change and see where this puts our app. So I'll launch Xcode. I'll scroll the table. It's still performant. I'll hit import. The app still scrolls smooth. It's not blocking. But we can still see the time it took. This time it took a minute. So we went originally from 5 minutes, went down to 480 or so, then we went to 120. Now we're less than a minute. So we've definitely made some major improvements. And so if you go this approach, some things you should know is that you can't pass objects between these 2 persistent store coordinators. You can't pass object IDs between these persistent store coordinators. You can use URI representations. That's about all you can do. Merge changes from context did save notifications still do work. But really, you just want to know which one should you use. And in my opinion, you should probably just stick with this tried and true approach. It's very performant and handles most cases. Even if you have that scratchpad use case I mentioned for the parent context, you can always just use an undo manager to get the same functionality. And so for concurrency models, you should use the simplest model that meets your needs and only update the main context after the large imports have been complete. And so when I talk about core data, often I want to bang my head. But I hope that I gave you a couple things here that maybe you don't want to bang your head as much as I have in the past. And so in summary, Use the tools, make objective measurements before you change things, and don't load more than you need to in memory. Don't use case and diacritic insensitivity. Be smart with your data model, do imports in batches, and pick the correct but simplest concurrency model.